So here we are giving the function s of t equals t to the fourth minus 8t squared plus 16, where t is greater than or equal to 0, and we're asked several questions about velocity, acceleration, and speed. There's a question here, when is the particle speeding up and when is it slowing down? And I want to talk about how to answer that one. Speeding up, what is speed here? Okay, so speed is like velocity, but it does not have a sign associated to it. Speed is the absolute value of velocity. So if an object is moving backwards, it would mean that velocity was negative, but its acceleration was also negative, then it would be speeding up because it's going this direction and it's going this direction, which would be backwards faster. So this is one way that you could have something be speeding up, is if your velocity is negative, which means you're moving backwards, and your acceleration is negative, which means that your velocity is getting more negative. Another way that you could have a particle be speeding up would be if you had both acceleration and velocity be positive. So we'd be checking for where is the acceleration positive and the velocity positive, because then the particle would be moving forward and the rate at which it's moving forward would be going faster. So these are the two cases we want to look for. Now, to determine where the velocity is positive or negative, we can use the first derivative. So we're going to look at s prime of t is equal to 4t cubed minus 16t. We're going to see where is this equal to 0. So I get 4t cubed minus 16t equal to 0. So I can factor out a 4t here. I get t squared minus 4 is equal to 0. So I'm going to have that the solutions of this are t equals -2, 0, or 2. But t is greater than or equal to 0, so I can get rid of the -2 one. So I'm going to have 0 and 2 as important parts here. And I can ask what the sign of the velocity is by plugging in a representative point. Here I'm going to pick 1 between 0 and 2. So s prime of 1 would be 4 times 1 cubed minus 16 times 1. So this velocity would be negative here. And then if I look from 2 to infinity and look test looks like s prime of 10, I would get 4 times 1000 minus 16 times 10, which is certainly positive. So here the velocity would be positive. I'm going to copy that information over because I need it. So I know that the velocity is positive on 2 to infinity and negative on 0 to 2. Now I also need to figure out this information for the acceleration. So the acceleration here would be s double prime of t is equal to, I'm taking s prime of t was equal to 4t cubed minus 16t. So s double prime of t will be 12t squared minus 16. And I'm going to be solving this here for 0 so that I can then figure out where it's positive or negative. So I can divide through by 4, make this be 3t squared minus 4 equals 0. And if I solve this, then I get 3t squared is equal to 4, and I divide both sides by 3. So that gives me that t squared is 4/3. And that means that t is equal to positive or negative square root of 4/3. But since this function is only defined for t greater than or equal to 0, I'm going to drop this and just have t equal to the square root of 4/3. So now I'm going to make a second chart for my acceleration and see where does this second derivative, where is it positive or negative? So I can test 1 because it's in the interval 0 to square root of 4/3. And when I plug in s double prime of 1, I'm going to get 12 times 1 squared minus 16, which is -4. So here the acceleration would be negative. And I can pick something on the other side of that, like s double prime of 100, which would be 12 times 100 squared minus 16, which is certainly positive. And I don't know what square root of 4/3 is exactly. It's smaller than 2. So here's what I have. I have that the velocity is positive. I have that the velocity is negative on 0, 2, and positive everywhere else. And I have that the acceleration is negative from 0 to square root of 4 over 3 and positive everywhere else. So these two places where the acceleration and the velocity agree would be where this is speeding up. In other words, from 0 to square root of 4 over 3, union with 2 to infinity. All right, so it took me a moment to figure out how to put that in. You need to do interval notation and be sure to use capital I and F for infinity here. And then look at the capital U that stands for union to join the two intervals together. Slowing down is just going to be the opposite. It's wherever the velocity and the acceleration have opposite signs. And I check those answers. And yeah. So the key insight here is when we talk about speeding up, we're asking where do the acceleration and velocity have, or the velocity and the acceleration have the same sign? And when we talk about slowing down, we're asking where do the acceleration and the velocity have opposite signs?